All right. Welcome to CXC Math TV. Today we're gonna go through the CAPE Integrated Mathematics Paper 2, and this is, as you can see, it's 2018. All right. As I promised, I wanted to do one video a day. All right. So, still trying to do that. This is 2018 paper. Let's do it and have some fun. All right. So the first question, right? By the way, module one is from Foundations of Mathematics, so like surds, logarithms, indices, factor and remainder theorem, trigonometry, matrices. These are module one. Module two is statistics, and module three is calculus, so limits and continuity, differentiation, and integration. That's the structure of the paper for integrated math. So let's get into this question here. So now it says solve for x, the equation 3 to the x plus 1 over 27 equal 9. So first thing we can do is change everything to the common base. So this is 3 to the x plus 1 over, remember, 27 is really what? 27 is 3 cubed, and that's equal to 3 square. Now what we can do now is, remember, when you're dividing and the bases are the same, you're subtracting the power. So this is 3 to the x plus 1 minus 3 equal to 3 squared. Then by laws of indices, when the bases are the same and we're raising to some power, we can just equate the powers. So that means x plus 1 minus 3 is equal to 2. So x minus 2 is equal to 2. So x is equal to 4. That's it. Finish. Now I love when you always test your answer. If x equals 4, let's test our answer. So we bring out our calculator and test our answer. I'm just testing the answer. 3 fraction button. 3 raised to the 4 plus 1 divided by 27. We should get 9. We do get 9, so 4 is correct. Easy, easy, easy. That's our answer. This question, it says, by solving the equation below, show that the base a is equal to 10. So solving this equation, the rule of logarithm says log a minus log b is equal to the log of a over b when the bases are the same, right? So in this case, this becomes log base a of, this is now 25 divided by 0 0.00, no, it's not 20, 0 0.025. All right, so divide it by 0 0.025, and we equate it to 3. Now we have to remember the definition of logarithm. Definition of logarithm. All right, first simplify that before we use the definition. So simplify, of course, 25 divided by 0 0.025. And that's giving you 1,000. So this is log A of 1,000 is equal to 3. The definition of logarithm is telling us that a to the third power is equal to 8,000. So the rule we have to remember is if in the form log of the base of a number equal to a power, then the base to the power is equal to the number. So that means the base a to the power 3 equal 1,000. So we can then cube root both sides. So a is now the cube root of 1,000, which is 10. That's it. So we do the proof. 4 marks again for that. Easy. So we got 8 easy marks. Nothing too ridiculous. Alright, so that's it. Alright, this part now. It says the following diagram shows f of x equal e to the x, and it says sketch on the same axis the graph of f inverse. So remember, the inverse is a reflection in the line y equal to x. Remember, the inverse is a reflection of the line in the line y equal to x. I love to draw my line y equal x. This shows to them that I fully understand what I'm doing. Right, this is the line y equal to x. Once I put y equal to x, now I'm going to reflect it. Notice this is the point when x is 0, y value is 1. I'm going to label it. This right here is when x is 0, y is 1. So the inverse point interchange x and y. So the inverse point is x is 1 and y is 0. So that's the inverse point. Now, another point we can see, another point now. Alright, so let's put on right here. This looks like, remember, it's a sketch. Alright, and if you did, there's two ways you can do it. This is just using some points and then doing that. Another way you could do it, of course, is remember to find the inverse. If you have a function y equal e to the x, then to find the inverse function, we just interchange x and y, so x equal e to the y, then make back y the subject, so log x is equal to log e to the y. And since we're using natural log, remember log e is 1. So we're saying then that y is equal to log x. So that's the inverse function. F inverse of x is equal to log x. That's what we're sketching. Alright, so we know that the log of 1 is 0, and then you can just put in the rest, like the log of 2. The log of 2 is 0.69. Alright, so when x is 2, we get 0.69, maybe somewhere here. Then put in the log of 3. The log of 3 is 1.1. 1.1 might be somewhere here. Alright, then we'll put in the log of 4, and the log of 4 is 1.39. 1.39 is somewhere 1.39. 1.5 is in the middle, so 1.39 right there. And the log of 5, this is 1.6. We go over halfway. And we can even put in now log of a half, and we know that gonna give us a negative number. So log, natural log 0.5, that is negative 0.69, somewhere right here. So we get the gist, and now we can sketch the curve. The curve looks something like this. Oops. Let me try and get that right. Something like this is the curve. Alright, and that's our inverse function. A reflection in the line y equal x, and you can of course label it and tell them this is f inverse of x equal to ln x. Easy 3 marks. Alright, nothing severe, nothing significant, nothing too hard. Now, the next part. The next part here now, it says an arithmetic progression has first term. And by the way, if you're seeing it a little blurry, I'm seeing it blurry too. When I download the paper, this is how I got it. So now it says an arithmetic progression has first term 4. So first term we use the letter A. And it says it has a common difference of 3. Common difference D is equal to 3. Let Tn be the nth term of the progression. So let Tn be the nth term. It says find the value of n for which Tn is greater than 103. So Tn is greater than 103. Now what's the formula for Tn in an arithmetic progression? The formula for Tn is equal to a plus n minus 1 times d. You have to know that. So this is a plus n minus 1 times d is greater than 103. What was a? 4. What was d? 3. So 3 in bracket n minus 1 is greater than 103. Subtract 4 from both sides, so that's 3 in bracket n minus 1 is greater than 103 minus the 4 is 99. Next thing we do is divide both sides by 3. So when you divide both sides by 3, we get n minus 1 is greater than, n minus 1 is greater than 99 divided by 3 is 33. So n is greater than 34. Now, since n is greater than 34, I want the smallest value for n. What's the next number bigger than 34? 35. So that's our answer. The smallest value n can be is 35. Very easy. Nice. part C. This part now, part D. It says an infinite geometric series is defined by 4, 8 over 3, 16 over 9. Evaluate the sum of all the terms of this series. In other words, they're asking you to find sum to infinity. Anytime you're asked to find sum of all terms, they're asking you to find sum to infinity. Now, sum to infinity is given by a simple formula that you need to remember. It's the first term divided by 1 minus the common ratio. So first thing, let's find the common ratio. The common ratio, remember, is the second term divided by the first term. So it's equal to the 8 over 3 divided by 4. I'll put that in the calculator. So put in 8 over 3 divided by 4. I'll plug that in, we'll get 2 over 3. Or you could even use the second term 16 over 9 divided by the third term, divided by the second term 8 over 3. And you'd still get the same 2 over 3. So the common ratio is just 2 over 3. Once you get the common ratio, now we use sum to infinity equal a over 1 minus r. The first term is 4 over 1 minus 2 over 3. Plug that in the calculator. Alright, so fraction button. 4 over 1 minus 2 over 3. And that gives us 12. So the sum to infinity is 12. That's your answer. Easy and straightforward. Really nice. The next part now, it says the matrix A below has unknown element P and the determinant is equal to 7. Alright, so they tell us that the determinant of the matrix A is equal to 7. Find the value of P. Now, to find the value of P, you have to remember that A is equal to, using the first row, let's say we're using the first row. Using the first row, it's a positive 2 times the determinant of cross the row and column with 2 in it. You'll be left with P00 minus 1. Then the cofactor signs, remember, are plus minus plus. So now this is minus 0 times the determinant of cross the row and the column with 0 in it. Minus 305 negative 1. Then we have plus 1 times the determinant of cross the row and the column with 1 in it. We cross out that and we're left with minus 3p50. Alright. Now that we did all of that, now we can go ahead and evaluate the determinant of A. It is now 2 times in bracket. Remember, it's multiply the leading diagonals. So p times negative 1 minus 0 times 0. Close the bracket. Minus 0 plus, because 0 times anything is 0, in bracket. 1 in bracket, negative 3 times 0, and then we have minus 5 times p, and remember that's equal to 7. So this is saying now p times negative 1 is minus p times 2 is minus 2p, minus 0, minus 3 times 0 is 0, then we have minus 5p, so 0 minus 5p, then we have it times 1. So 1 times minus 5p is minus 5p equals 7. So in that case now, minus 2p minus 5p is minus 7p equals 7, and so p equals negative 1. That's our answer. Now, guys, I strongly recommend getting one of these calculators. Look at it, because the new matrix then is 2, 0, 1, minus 3, minus 1, 0, 5, 0, minus 1. Now look what I'm going to do. I'm going to evaluate the determinant of that matrix. That's what I love about this calculator. We're going to evaluate and see if we get the determinant should be 7 when p is negative 1. So let's verify it. We'll go on mode, we'll go on matrix, and we want 3 by 3. Alright, this is 2, 0, 1, Well, I'll go back. This is 1 minus 3. That was minus 1. For P, this is 0. This is 5. This is 0. And this is minus 1. Now that it's stored, what are we trying to do? We're trying to evaluate now the determinant. Where's the determinant symbol again? It's somewhere here. This is just to check back the answer. Let me see, determinant. Don't pop up there. Shift then 4, and I want to find the determinant. Press 7. Determinant of the matrix that we just stored. And the matrix was stored. Was it matrix A? I think it was matrix A. And there it is. Determinant is 7. So indeed, we show that determinant of the matrix we stored was 7. And when it's -1, we get 7. And we know we're supposed to get 7. So this was just verifying our answer is correct using the calculator. Alright, now this question says solve the equation for x. So solving for x now, by the way, you can put an equation like this in the calculator as well. So get one of these calculator, guys. I'm telling you. But we're just going to do it to check our answer. First thing, bring over the minus root 3 to the other side. So we have 2 cos x is equal to positive root 3. Then we divide both sides by 2. So we divide both sides by 2. We're getting cos x is equal to root 3 divided by 2. So what you do is you draw your circle. And remember that all school teachers care. So we're in the quadrants where, since root 3 over 2 is positive, we're at where everything positive and cosine is positive. So the first value for x is going to be cosine inverse of the square root of 3 divided by 2. Then now you put that in your calculator. Cosine inverse, fraction button, square root 3 over 2. Now it's in matrix form, so let me put it in regular fraction form first. I need to change the mode. There we go. So cos inverse root 3 divided by 2, close the bracket, equal to, that's cos inverse root 3 over 2, 30, but that's in degrees. You want it in radians, so you change your mode to radian, so we press 4. So what we get is pi over 6, or pi by 6. So x equal pi by 6 is one answer. Now that's the answer for the first quadrant. You have to remember the fourth quadrant is 2 pi minus the first quadrant answer. So now you have to work out now 2 pi minus 5 pi over 2 pi minus pi over 6. I'll put that in the calculator and we get 11 pi over 6. So the next answer is 2 pi minus pi over 6, which is 11 pi over 6. So just to write it here now, our answers are pi over 6 and 11 pi over 6. That's it. Nice. Now you can always verify and check it. Check it. Just check it. Bring out the calculator. Alright, bring out the calculator, checking it, putting it in the original equation, minus root 3 plus 2 times the cosine of, supposed to be pi over 6, that should give us 0. And remember, your mode must be in radians. We get 0, so we know we're correct. And you can try with the 11 pi over 6, and we'll also get our 0. Really, really nice. This question now, it says, find the remainder when this cubic is divided by x plus 3. Now there's two ways to do it. First, method 1, you can set now I'm gonna do the synthetic division. I really want to show it off. Now the synthetic division, right? Instead of doing polynomial division, right? Um, write down the coefficients of each term here. X cubed, 1, 3, minus 5, 6. And then when you set x plus 3 equals 0, you get negative 3. So the first thing you do is bring down the 1, right? And that leave 1. Negative 3 times 1 is negative 3. Then we add them, we get 0. Then we multiply, we get 0. Then we add them, we get negative 5. Then we multiply them, we get positive 15. Then we add 6 and 15, we get 21. What this is saying is that from synthetic division, so from synthetic division, the remainder is 21. I don't know why the letters keep disappearing. And it's not even erasing. Oh, okay. It's erasing. It's just moving slow. Guys, as you can see, the computer been running from day. I've had a lot of extra classes from day. And so, of course, now it's a little late recording. The computer is tired. I'm a little tired. So if the video is, if I sound a little sleepy, bear with me. My apologies. All right. It's a little bit late. So now, right here, from method 1, we'd say using synthetic division. Using synthetic division, the remainder is 21. That's using the synthetic division. Alright, now let's say you didn't want to use synthetic. You have method 2. Method 2 now you could plug in negative. You could plug in negative 3. So f of negative 3 give you the remainder. So f of negative 3, so the remainder is then equal to, so let's plug it in. So the remainder equal, plug it in. This is now negative 3 cubed plus 3 times negative 3 squared minus 5 times negative 3 minus 6. Then from there, that's calculator job. Bring out the calculator, bring it out, bring it out. Negative 3 cubed plus 3 times negative 3 squared minus 5 times negative 3 minus 6. Put that in the calculator. And we get 9. So that means I'd have made a mistake somewhere because this is saying remainder is 9. Where was, oh, I hope you guys would have seen the mistake. And so the remainder is not 21. Right here is a mistake. The coefficient wasn't 6. This is supposed to be. Let me put it in black, negative 6. And negative 6 plus 15 is 9. So my bad there. As I said, guys, it's a little late. You know, don't make these mistakes. It don't matter. Don't make these mistakes. But this right here, negative 6 plus 15 is 9. That would be the remainder. And so let me change this using synthetic. The remainder is also 9. Right? But it's really fun though. Whichever way you do it, I want you to feel confident in that method. Now this question part B, it says rewrite the equation of the line. Rewrite the equation in the form y equal mx plus c. So the first thing you do is you cross multiply. Cross multiply. So cross multiply. We multiply 2 plus x times 3 equal to 5 times y minus 4. Expand it in 3 times 2 is 6 plus 3x equal, this is now 5y minus 5 times 4 is 20. Now, we want y to be on one side, so bring over the minus 20 to that side. So 6 plus 20 plus 3x equal 5. And then now 6 plus 20 is 26. So this is saying 5y equal 3x plus 26. Now I just put the 5y on that side, alright? Nothing is wrong with that. Then you divide through by 5, so y is equal to 3 over 5x plus 26 over 5. And that's it in in the form y equal mx plus c. Easy. Nice. Now, the next part says calculate the acute angle which the line makes with the x-axis. To work out acute angle, the first thing I want you to do is draw a sketch. Drawing a sketch, first thing is that you need two things. You need the x-intercept and the y-intercept. It's always easier with those two. So the x-intercept would be if you put y as 0. If you put y as 0, you'd be getting 3 over 5x. Then put y as 0 from here. So 3x plus 26 equals 0. Because the y is 0 for the x-intercept. So x would be equal to negative 26 over 3. Alright? So negative 26 over 3. Let's say it's somewhere right here. Negative 26 over 3. That's your x-intercept. And your y-intercept is positive 26 over 5. So somewhere right here, this is positive 26 over 5. Now the angle it makes with the positive x-axis, alright, so if we draw our line, this is the angle they want, alright. So that angle now, to find that angle, right, there's two ways you can do it. Now, what you need to remember is that the tan of that angle is equal to the gradient. The tan of that angle is equal to what? The gradient. So the angle then is equal to tan inverse the gradient. And so it is tan inverse of the gradient. Remember, the gradient of the line is 3 over 5. So tan inverse 3 over 5. You put that in the calculator. So tan inverse of 3 divided by 5. And we get 0.54 radians, but let's give them in degrees. 30.96 degrees. 30.96 degrees, which is approximately 31 degrees. Alright. Now, you could have, of course, used coordinate geometry and get this answer, but we're not doing all of that. This part now, it says, write the conjugate of the complex number 1 plus 2i. So the conjugate is change a plus to minus. So it is 1 minus 2i. Easy. 1 minus 2i. Now, this part now, it says express this complex number in the form a plus bi. So we have 1 minus 2i over 1 plus 2i. And remember, you then multiply it by the conjugate. And the conjugate is 1 minus 2i over 1 minus 2i. The dot keeps disappearing. Okay, so now when we stop it. So now when we multiply, alright, we multiply numerators first, that becomes 1 minus 2i times 1 minus 2i. And then the denominator is the difference of 2 square, 1 plus 2i times 1 minus 2i. Alright, so expanding it, right? So 1 times 1 is 1. 1 times 2i, that's minus 2i there. Then minus 2i times 1 is minus 2i. And then minus 2i times minus 2i is 4i squared. Now, we divide it now by 1 plus 2i times 1 plus 1 minus 2i. This is the difference of 2 squared, so you get 1 minus 4i squared. Now, simplifying, that's equal to remember, I squared is equal to negative 1. I squared equal minus 1. I squared equal minus 1. So in that case now, this is really minus 4. 1 minus 4 is negative 3. Then minus 2i is minus 4i over, now 1 minus 4i squared. I squared is negative 1. Negative 1 times 4 is positive 4. 1 plus 4 is 5. So it is minus, we can write this as minus 1 over 5 in bracket 3 plus 4i, or you can write it as minus 3 over 5 minus 4 over 5i, right? That's it. Put it whichever form you want, and then you can verify it with your calculator. We love this calculator. So the complex number, we'll just put it in complex mode. So change it to complex 2, or putting in the complex number 1 minus 2i over 1 plus 2i. Just to check your answer. Bam! Just like what we got. So we know we're correct. Now give me 1 minute. Let me plug in my computer. Alright. Alright, so I just got to plug in the computer. Alright, great. So now moving right along. 6 marks to do that. That was so easy. Alright, now functions part. Now it says find the value of g of minus 2. So all we're going to do is input x value as minus 2. G of minus 2 g of minus 2 is equal to, where x is negative 2, we'll put 2 plus negative 2 cubed. Now sometimes you're not that confident, put in the calculator, no problem. 2 plus negative 2 cubed. Put in the calculator, we'll get negative 6. So that's it. It's equal to negative 6. That's g of minus 2. We'll finish. No problem. The next part says show that the composite function g f of x is this right here. So all we have to do now is input f of x into g. So g f of x is going to be equal to, where x is in g, put f of x. So this is 2 plus, where x is, we put f of x cubed. So that is equal to 2 plus f of x, remember, is x minus 1 cubed. Now this we're going to do some binomial expansion now. So 2 plus, remember the binomial expansion? Remember this formula for me, please. A plus b all cubed equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. But in this case, our b is minus 1, so it is plus x cubed plus 3x squared times b, which is negative 1, plus 3x times negative 1 squared plus negative 1 cubed, using that formula. So now it is 2 plus negative 1 cubed is 1 plus x cubed. Then this becomes 3x squared times minus 1 is minus 3x squared. Then minus 1 squared is 1, so that's plus 3x. Then all we have to do now is flip it around and rewrite it in descending power. So this is x cubed minus 3x squared plus 3x plus 1. Alright, shown. You do a proof like that, you tell them, easy. That was easy. Nice. Or you can tell them soft. Whatever you want to tell them, that's fine. And look at that. Question 2 is finish. Finito. So finish module 1. And now we're on to module 2. Module 2, my favorite module is statistics. So it says here, the attendance of a class of 26 students was observed for 65 days during a school term. The number of days the 26 students were present is listed. They have somebody come in, out of the 65 days, somebody comes 60, 42, 39, 50, 62, and all of that good stuff. But somebody came only 12 days out of 65. This person don't even come school for 3 weeks. That's crazy, right? But that's how it is, that's how it is. But we need to create a ordered stem and leaf. So remember to create the stem and leaf now. Alright, so we have our stem and our leaf. It's fairly straightforward. So our stem, and over here we have our leaf. Now we notice that for the stems, Right? We notice that it's the lowest is 12 and the highest is 65. So we can put 1, 2, 3, 4, 5, 6. Now, going in order, all right, the least number of days somebody was present was 12, so we put that 2. Is there anybody else in the teens? Nope. Let's go in the 20s now. Do we see any 20s? 20s, 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 no 20s, no 20s. Nope, no 20s, no 20s, no 20s. Then we'll go to the 30s. Do we see any 30s? 30s, 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 30s. I see a 39. Any more 30s? So I just put a 9 here. Now we go into the 40s. 40s. What's the lowest 40? Do I see a 41? No 41. I see a 42 here. So I put a 2 there. And then now I'm looking. Do I see a 42? Another 42? Nope. Do I see 43? 43? Nope. But I see 45. Do I see another 45? We're looking. Nope. I see 46 and 46. I know I put 6 and 6. Do I see any more 46? Nope. So I'm looking 47. Don't see any 47. I see 48. So I put 8. And I see any more 40s? I see 49 here. So I put a 9. Now I go into the 50s. So notice I see 50 flat, a 0. And then I notice I see, do I see 51? I don't see 51. Do I see 52? 52. I do see 52. Do I see 53? I do see 53. Do I see 54? No, I don't, but I see 55 twice. Do I see 56? No, I don't. 56. Do I see 57? No, I don't. Do I see 58? Yes, I do. Do I see 59? Yes, I do. Then I see 60. Then I see 60 again. Then I see 60 again. Then I see 61. Then I see 61. And notice I missed out this 58. That's what I love about underlining every number we use. So I notice I missed out this 58. So I go back and put the 8 there before the 9. All right. I see 61, 61. Which other numbers leave? I see 62. Yes. Do I see 63? And I missed out one more 60. That's why I love doing it this way. So I'm going to put in another 0 somewhere here. All right. So my recommendation, always tick off the numbers that you use. All right. So the 62, then we have the 63. Then we have, which other number is missing? 64, nope, I see 65, so I'll put 5. Now, the last thing for you to do with doing stem and leaf is to add everything and you should get the total frequency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So one is missing. Which number is missing? The last number, this 65. See, because I didn't take it off. That's what I love about doing it this way. Now, next thing you have to do is put a key. Tell them your key. 3/9 means 39. Now we'll finish. Easy 4 marks or 3 marks, but 5 marks they gave for that. Whoa. Now it says using the stem and leaf or otherwise determine the value of the following. The mean. We're going to go with otherwise, alright? So otherwise for the mean bar x, remember, is the sum of x over n. So now all you're going to do is add up everything, alright? So let's now find now the sum of x, just to put here, the sum of x would be add up everything, everything. 2 plus, well, not 2, 12 plus 39 plus 42 plus 45 plus 2 times 46, because there were two 46, plus 48 plus 49 plus 50 plus 52 plus 53 plus 2 times 55 plus, we have 58 and it's two of them, so 2 times 58 plus 59 plus, we notice we have 4 60s, so 4 times 60 plus 62, and it's, well, 2 times 61, then we have plus 62 plus 63 plus 2 times 65. Close the bracket. That's the sum. The sum is 1,384. 1,384. Once we get the sum is 1,384, this is 1,384 divided by n, and n is 26. So now we just put in that and we divide it by 26, and that's the mean. The mean is 53.23. Now it says now determine the mode. The mode from the stem and leaf is just 60. If you remember, the mode was what? The one that occurred most frequently, and from the stem and leaf we can identify the mode. 4 times 60 occurred. Now the median is the middle number, and there's 26 of them, so the middle number is half n plus 1 to get the median position. So half 26 plus 1 is half of 27, which is 13.5. 13.5 is in between the 13th and the 14th term. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 13 and this is 14. We're in between 55 and 58. So the median is 55 plus 58 divided by 2. Put that in the calculator. 55 plus 58 divided by 2. In that case, we get 56.5. That's your answer, 56.5. Now it says choose the most suitable central tendency for the mean, mode, and median for the data and give a response. Now, now, first thing we noticed was what? The mean is less than the mode, and the mean is less than the median. So in that case, it is negatively skewed. When the mean is less than the median, which is less than the mode, it is negatively skewed. So we can tell them the distribution is negatively skewed. And whenever a distribution is negatively skewed, the best measure of central tendency is the median. So you need to know this distribution is negatively skewed, and so the best measure of central location or tendency is the median. All right, since the distribution is negatively skewed, all right, then that's what happened. All right, since it's negatively skewed. Cool. Now, it says describe the shape of the, see there, we literally use the reason to answer 3, and now we're going to describe the shape. All right, so again, to describe the shape, the mean is less than the mode, hence distribution is negatively skewed. Or some people like to call negatively skewed left skewed. Alright, the distribution is left skewed. Now since it is left skewed, it says suggest a reason why the distribution has this shape. Now, one possible reason why it is negative skewed is possibly because of the outlier. One possible reason is due to the outlier 12. Alright? Now, why do we call it an outlier? We notice that the lowest, everything is bunched between 39 and 65, right? Everything is bunched right there. But notice we skip a row, we skip out 20s, and then the lowest is 12. 12 just don't fall in place, right? So one possible reason is due to the outlier 12. Well, actually, you could verify if 12 is a outlier using the formula what? Q1 minus 1.5 times the interquartile range. That would tell us if it's actually an outlier, but we'll get the gist. Due to 12 being so far away from the next number, that's the reason why the shape is negatively skewed. 12 affect it big time. Now part B. Part B says 10 students sat two different math tests. The first test was a multiple choice and the second test was an extended response type. Both tests were marked out of 30. Let X and Y represent the marks obtained for the first and the second test. Shown some summary statistics of the marks obtained by the 10 students. Show that the B in the linear equation y hat 1 equal to a plus bx for the marks obtained of the expensive response against the marks obtained in the multiple choice is 0.96. Show that B is this. Now to do this question, you just need to remember the formula. Remember B is equal to n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. That's the formula for B. So remember, just writing it back here, n times the sum of x minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. That's the formula used to find B. So now, you can go ahead now and work it out. In this case, B is equal to n times the sum of xy. So it is, n is how much? 10. So 10 times 3733 minus sum of x, 165, times sum of y, 191, over n times sum of x squared. So 10 times sum of x squared is 3327 minus sum of x all squared. Then you put that in a calculator. I'm going to work out numerator first. 10 in bracket 3733 close the bracket minus 165 times 191. That gives us 5,815 divided by, then we have 10 times 3327, then we subtract 165 square, and we get 6,045. Then we do the division, 5815 divided by 6045, bam, 0.9619. which is, or B is 0.962. That's how we do this question. Easy, no problem. It's just formula. Now that we get our B value, alright, now that we get the B value, let's say now determine the equation for the estimated linear regression. Determine the equation for the estimated linear regression for marks in the extensive response. Determine the equation. Now remember the equation is y is equal to AO plus BX. Alright, A, we need to find A. We already know B. So now remember A is equal to the sum of y minus B times the sum of x over n. That's the formula for A. So in that case, now we can tell them our constant is the sum of y minus b times the sum of x over n. So now put that in, sum of y, 191. So put 191 minus b, which is 0.962, times the sum of x, and the sum of x was 165 over 10. I'll put that in the calculator. So A equal, fraction button, 191 minus B, which is 0.962 in bracket 165 over 10. Put that in the calculator, and what we get is 3.227. 3.227. So now we can go ahead now and say y is equal to 3.227 plus 1.96x. And that is our regression equation. That's our linear regression equation. Fairly straightforward, easy. 4 marks for that. Now it says a student writes the multiple choice test, scores 20 marks, but is absent for an extended response. Use a linear regression to estimate a mark to the nearest whole number for the student for the extended response paper. So all we're going to do is say y is equal to a plus bx. Now, if him score is 20, x is 20, this is 3.227 plus 0.962 times x, and x is 20, that's equal to plus 0.962 in bracket 20. We put that in the calculator and we get 22.4, 22.46, 22.467, which is approximately 22 marks. That would be his estimated marks for the structured. Nice. Moving right along. Question 4. Question 4 now, it says a man traveling to work by car has to pass 3 traffic lights. The probability that he meets a red light at the first traffic light. So I love to do a tree diagram to show this. This is just me. You don't have to. So I have first light, second light, and we have third light. Now, the first light, it says a man has, it says probably that he meets a red light at first is 0.4. So him go, it's either meet a red or it's not red. Chance him meet a red is 0.4. And then chance that him don't meet a red then is 0.6. Cool. Now, for the second light, it says the probability of meeting a red at the second light is 0.3. So now if we go to the next one, red or not red, to meet a red on the second one is 0.3. Alright, it's really bothering me. Let me move myself over here and the tree over here because this is giving me some issues. So this is the first one, red or not red. And remember, it is 40% and 60%, 0.4 and 0.6. That was the first light. Now the second light, right? Now the second light now, red or not red, they said that it was 0.3. So 0.3, 0.7, 0.3, 0.7, red, not red. Finally, the last one now, they said that on the third traffic light now, on the third traffic light, the probability of getting a red light at the third one is 50%. So the third one is 50%, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Red, not red, red, not red, red, not red, red, not red. I just like to use a tree diagram. You don't need it. Right? I just like to use it. Now it says find the probability that a man has to stop at the first. Find the probability that a man has to stop at the first traffic light only. Now, if the man has to stop at the first traffic light only, what we're trying to find is the probability that him get red and then him get green, green, or red then not red, not red. Right? If he has to stop at the first traffic light only, first, this way him go then. So him go red first, then him go not red, then what? Not red. So him go red, then not red, then not red. This is the route that him would go. So it is 40% times, these are independent events, so then times 70% times now 50%. Put that in the calculator. So put in 0.4 times 0.7 times 0.5, which is 7 over 50 or 0.14. So there's a 14% chance he stops at traffic light 1. So the first traffic light. Now it says show that the probability that the man has to stop at only one traffic light is 0.44. So now it says show that the probability him stop at only one traffic light, so the probability that he stop at one light only, one light stop. So if him stop at only one light, then it's different routes it could be. That's equal to the probability. It could be what? To stop at one light, it could be this one a while ago we just worked out. It's red, then not red, then not red. Plus, it could be what else? It could be not red first, then red second, then not red. It could be not red first, then red, then not red. Or the last one, it could be what? It could be not red, then red. Not red, then not red, then red. So we're saying it could be that you stop at the first light, or it could be that him stop at the second light, and then it could be that him stop at the third light. Any one of those three is just one red light. So we add up all the probabilities, so it's equal to, the first one we already worked out was 0.14, plus now the second one to go not red, let me circle it in black, because this one not red, then not red would be this. So it would be 0.6 times 0.3 times 0.5. Then finally, the last one would be plus, not red, then red would mean 0.6 times 0.7 times 0.5. Now put all of that in the calculator and it should give us 0.44. That's what they're saying. So let's do it. Let us do it. Plus 0.6 times 0.3 times 0.5. And I'm going to work each of them out separately so you can actually see it. Let me work it out separate. 0.6 times 0.3 times 0.5. That one is 0.09. This is now 0.14 plus 0.09 plus the next one now is 0.6 times 0.7 times 0.5, and that is 0.21. Then now we add them. So 0.21 plus 0.14 plus 0.09. We add them and we get 0.44. And that's it. And we're done. Nice. We get our 0.4 marks. And it's shown and it's easy. Now, this question here, it says now, a committee is to be selected from an organization where the number of men is twice the number of women. And it says, describe a suitable sampling method for selecting the gender distribution of the organization. Now, one way to do this to ensure that we're getting way of doing this to ensure that we're getting double the mean as women is we could use stratified sampling. So we may use stratified random sampling where we divide the groups into two stratas, men and women, and select randomly double the number of men to women. That's it. All right, so we're going to use stratified random sampling. All right, that's the best way. All right, it says a suitable method, right? You can describe another suitable method. That's fine. All right. Now it says here, it says a committee of 4 is to be chosen from 5 males and 6 females. And it says so as to contain exactly 2 males. Calculate the number of ways in this. This can be done. Now the committee do what? Another committee of 4 is chosen from 5 males and 6 females. So we're choosing, what are we choosing? It says so as to contain exactly 2 males. So we need to choose 2 males out of how many males there are? 5 multiplied by, we're choosing now, how many persons make the committee? 4. So we need another 2 persons on the committee out of the 6 females. Alright, so calculate the number of ways in this can be done. 5 choose 2. You put that in a calculator. 5 choose 2, which is 10, times 6 choose 2. And you put in 6 choose 2 in a calculator, which is 15. And 10 times 15 is 150 ways. There's 150 ways in which we can choose exactly 2 males, and to ensure 2 males is on the committee. There's 150 ways we can do this. That's fairly straightforward and easy, and yeah, it's nice. This part now, it says, for a particular plant, the probability that seed germinates is 0.7. It says, determine the mean number of seeds that would germinate in a package of 15 seeds. In this case, let the seed be x, so x follows a binomial distribution of n, p, and so now the mean, remember, is expected value of x. This is n times p. So the mean is 15 times 0.7. Put that in a calculator. 15 times 0.7, which is 10.5. So 10.5 seeds. That's expected. Alright? Easy. Now part 2 says calculate the probability that the package of 15 seeds chosen at random will contain exactly 13 seeds. So we need to find the probability x equals 13. Any random package. Now remember the formula for binomial. The probability of x equal to, let's say x equal to a. The formula is what? N choose a. This is now p to the a, q to the n minus a. So in this case, the formula going to be n, which is 15. 15 choose a is 13. P, which was 0.7 to the 13 times q, and q is 1 minus p, that's 0.3 to the 15 minus 13 is to the second power. And you put that in the calculator, it can't get any easier. Take out the calculator, 15, choose 13, multiplied by 0.7 raised to the 13, multiplied by 0.3 square. We work that out and we get 0.09156. That's our answer. And we'll move on. That's it. Easy. No issues. Alright. Now part D, it says the lifetime of a bulb may be modeled by a normal distribution. So X follows a normal distribution, mean 6,000 hours, and a standard deviation of 45. Now it says the lifetime of one such bulb was 5,910. Calculate the z-value. So the z-value, remember, is x minus mu over sigma. So it's x minus the mean. X value given was 5,910. So 5,910 minus the mean given was 6,000 over the standard deviation value given, which was 45. Pump that into the calculator. The z-value is -2. Nice. Now it says, on the following diagram, shade the area that would represent the probability that a random bulb selected will last more than 5,910. So the probability x is greater than 5,910. This is really the probability z is greater than -2 because we worked out the z value from above. Now, all you need to do basically now is shade the region z greater than -2. Z greater than -2, you look. Ask yourself the Dora the Explorer question. Do you see -2? Yes, we see -2. -2 is here. So shade the region greater than -2. That's what they asked for. Then they say now, determine the probability that the bulb will last more than 5,910. By our shade, it's more than 50%, it's more than 60%, it's more than 70%. It's like 80 something or 90 something. But you're going to have to use your normal table now to work out the probability z is greater than -2, which is equal to the probability z is less than 2. So now let's use our normal table. Going into our normal table. So here it is. We're looking for z being 2. Here's 2.0 at 0.9772. This is it in our normal table, 0.9772. So in that case now, this is now 0.9772. That's our answer. Very easy. And guess what? Module 2 is now complete. Nice. We're in module number 3 now. Module 3 is calculus, and it always starts with limits and continuity. It says find the value of a for which the function f is continuous at x equal to -1. So all we have to do now is, if it is continuous, if f of x is continuous, then what do we know? Then we know that the left-hand limit, the limit as x approaches 1 from the left of f of x, should be equal to the limit as x approach 1 from the right-hand side of f of x. So we plug 1 into both functions, it should give us the same y value. So that means 1 to the 4th power minus a should be equal to 2 times 1 plus 7. Is 1 or -1? -1. Let me put on my negatives. -1 to the 4, 2 times -1. -1 to the 4 is 1, so this is 1 minus a equal 2 times -1 is -2. -2 plus 7 is 5. So bring over a would be equal to 1 minus 5, and 1 minus 5 is -4. So a would be equal to -4 to make the function continuous. Very easy, straightforward, no problem. Now it says differentiate the following with respect to x. 3 cos x ln x. Now we have to use product rule. Alright, so product rule tells us if y is equal to first function times the second function, Then dy dx is equal to keep the first times the derivative of the second plus keep the second times the derivative of the first. So in this case, dy dx equal keep the first. Our first function is, this is our f, 3 cos x. So 3 cos x. And if you want, you can write it somewhere here. So f is 3 cos x. So the derivative of the first is when you differentiate cos, you get negative sine x. Alright, so when you differentiate cos, you get minus sine. And you can also write down for your second function now, ln x. When you differentiate ln, you get 1 over x. So now we can tell them dy dx equal, keep the first times the derivative of the second, 1 over x, plus keep the second now, ln x, times the derivative of the first, which is negative 3 sine x. And to simplify our answer, this is now 3 over x cosine x minus 3 sine x ln x. That's our answer simplified. That's it. 3 marks for that, right? 4 marks, a matter of fact. Very easy for dy dx. Now this one now, we use quotient rule. For the second one down here, we use quotient rule. You have to remember quotient rule, that if you have y equal, a lot of people learn it as VDU or UDV minus VDU over V square and all sorts of fancy formula. I can't remember it that way. So I've always remembered is if y equal T over B, so top over bottom, since it's a fraction, you have a top and you have a bottom. And dy dx is equal to, start with the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. That's the formula. So the top is e to the 5x. So the derivative of the top, or t prime, the derivative of the top is 5e to the 5x. Then we have our bottom. Bottom is sine x. When you differentiate sine, you get cos x. So now we can use the rule that says dy dx is equal to, you start with the bottom. Always start with the bottom. You start with the bottom times the derivative of the top. Then the formula says we minus the top times the derivative of the bottom. And then this is all over the bottom square. All over sine x all square. So simplifying our answer, dy dx is equal to, we notice we can factor out e to the 5x from the numerator, and we're left with, from this side we're left with 5 sine x, from this side we're left with minus cos x, close the bracket, over, this is now sine square x. So that's our answer, dy dx is e to the 5x over sine square x in bracket 5 sine x minus cos x. That's dy dx. Finish. 5 marks for that. Very easy. No issues at all. Now this part now, it says a function of two variables is such that it's given by this, and it says determine an expression for the first partial derivative with respect to y. First partial derivative is written as dou f by dou y. That's the first partial derivative with respect to y. When you're differentiating with respect to y, then x is held as a constant. Go and check out the video that we have on this channel on partial derivative. Alright, so now when you differentiate x and you're differentiating with respect to y, this is a constant, so it becomes 0. Plus, we differentiate now 2y. Now remember, y is what we're differentiating with respect to, so when you differentiate 2y, you get 2. Plus, now we have xy cubed. The rule says we do what? Carry down the power. Then we subtract 1 from the power. Then multiply by the derivative inside the bracket. It's chain rule. Now the derivative of xy is just x. When you differentiate xy with respect to y, you get just x. Drop off the y. Alright? That's all. It's just like if I ask you to differentiate with respect to x, 3x. You just tell me 3. Alright? Differentiate 3x, you get 3. So if you differentiate xy, and x is a constant, x is a number, like 3y, then you just get 3. So that means dou f by dou y is equal to 2 plus 3 times x is 3x in bracket xy all square, and then you can simplify it as 2 plus, this is x square y square, so it's really 2 in bracket 3x, let's say x cube times y square if you want to expand it out, and that's it. 4 marks for that. Easy. This part now, it says the function f of x, this cubic function here, determine the critical values. The critical values, these occur, so when these occur when f prime of x equals 0, when the first derivative is equal to 0. So the first derivative would be differentiate 2x cubed, carry down the power, then you subtract 1 from the power, that's 6. Then subtract 1 from 3, we get 2, minus carry down the power, 2 times 15 is 30, subtract 1 from the power, plus differentiate 36x, you get 36, and you set it equals 0. Then now we can divide through by 6, so it becomes x squared minus 5x plus 6 equal to 0. Then we need to solve this quadratic. Now, is it 2 and 3? I would hope so. Factorize x. 3 times 2 give me 6. Signs are different. Well, signs are the same, both are negative. So the critical values are x equal to and x equal to 3. And we finish. Those are our critical values. Now, if they wanted critical points, it's always good to find your critical points. So when the x value is 2, plug 2 in this function. Then when x value is 3, plug it into that function to get your critical points. Plug them in. Just plug them in. So we have 2 times 2 cube minus 15 times 2 square plus 36 times 2 minus 24. And we do that and we get 4. Then now plug it in. Alright, we'll plug it in. 3, 3, 3. So 2 in brackets, 3 cubed minus 15 in bracket 3 square plus 36 in bracket 3 subtract 24, and we get 3. So 3, 3. Those are our critical points. But they only wanted the critical value, so we finish right there. Very easy. No problem at all. Now here it says determine the nature of the stationary points corresponding to the critical values. Now there's 2 ways to determine the nature. 2 ways to determine it, you can draw the sketch. So drawing the sketch, the lower x value is the maximum point. So this one, the 2, 4 is going to be your maximum. And then your 3, 3 is your minimum. Alright? So we could tell them from a sketch of the graph, we can tell them 2, 4 is our maximum stationary point, and 3, 3 is our minimum stationary point. And that's it. Nice. Now, another way you could do it now is with the second derivative test. That's f double prime prime. So f double prime would be differentiate 6x squared, you get 12x, minus differentiate 30x, you get 30. Now what you do then, so this is method 2, this is the second derivative test. F double prime of 2 would be 12 times 2 minus 30, which is equal to negative 6, which is less than 0. When the second derivative is less than 0, it frowns, and so it is a maximum point. That's 2, 4. And then now the second derivative at 3 is equal to 12 times 3 minus 30, which is 6, which is greater than 0. When it's greater than 0, we smile. And when it smiles, then that means it's a minimum point. Minimum point is 3, 3. So whichever way you choose to do it to get the max or the min point, that's fine. That's really fine. All right, nice. Now question 6 here. Question 6, it says determine each of the following indefinite integrals. So now, when you integrate 4, there's no x, so you're going to get 4x. So integrate it, we get 4x. Plus, when you integrate sine x, you get minus cos 5x, but then you have to divide by the derivative of 5x, which is 5. Then they say use c as your constant of integration. Just put plus c. You're done. So the answer is 4x minus cos 5x over 5 plus c. The next one now is to integrate 1 over the square root of 2x plus 1. Now, this one looks tricky, but there's two ways to do it. Alright, I'm going to do it by what we call a u substitution. Alright, so let u equal 2x plus 1. So if u is 2x plus 1, then du is equal to du dx is equal to, when you differentiate 2x, you get 2. So we can cross multiply or flip them to say, that du divided by 2 is equal to dx. Why did I do that? And I'm going to call this integral I. So now I'm saying I is equal to the integral of 1 over the square root of 2x plus 1 dx. But this dx now becomes what? The dx becomes du over 2 by transposition. So it's 1 over dx, so say becomes du over 2. And then now this becomes square root of 2x plus 1, we'll call that u. So that means we're just integrating now. We're integrating 1 over 2 times the square root of u du. Now integrating with respect to u, it becomes, rewrite this as 1 over 2u to the 1 over 2u to the half du. And then we can now integrate that. Now when the u is in the denominator, it becomes the integral of 1 over, now u to the half in the denominator, when you bring it up to the numerator, becomes u to the negative half. So in that case, it is u to the minus half over 2 du. Then the rule of integration says add 1 to the power, minus half plus 1. Add 1 to the power, and then we divide by that power. So we already have the 2 here, but we divide by the new power, minus half plus 1. And the new power is half, put our constant of integration c. Now just to finish it off, now that is minus half plus 1 is half, and u to the half, this is now u to the half, over 2 times half is 1. So we get 1 plus c. But remember, what is u? Remember u was what? 2x plus 1. So this is 2x plus 1 to the half power. But half power is square root. They'll put plus c. So that's what it works out to be. The integral of 1 over the square root of 2x plus 1 dx is just the square root of 2x plus 1 plus c. That's our answer. Easy, easy, easy. That was nice, right? Nice. Now this question now, it says, given that f of x is x squared plus 3x, we need to evaluate the definite integral. So now they're asking us to evaluate this. So we need to find the integral from 0 to negative 2 of f of x, which is x squared plus 3x dx. So the rule says we add 1 to the power x cubed over 3 plus add 1 to the power 3x squared over 2. And we're going from, I wrote the limits wrong. This is from minus 2 to 0. So going from minus 2 to 0. So first put in the 0 part. That's 0 cubed over 3 plus 3 times 0 squared over 2. Subtract, when we put in the negative 2 now, that's negative 2 cubed over 3 plus 3 times negative 2 squared over 2. And then we punch that into the calculator. So punching that into the calculator, we get this part work out to be 0 minus this part now. We'll put this part in the calculator fraction button, minus 2 cubed over 3 plus 3 in bracket, well, let me do fraction button, 3 in bracket minus 2 square over 2. And this works out to be positive 10 over 3. So when we work it out, this part is positive 10 over 3, so we're getting negative 10 over 3 as our answer. Now, when you get negative 10, it's always, you're not so sure. So I always say double check your answer with the calculator. Guys, buy one of these calculators. Come on, man, buy one. So now I'm going to change the mode, and we're going to integrate. And we're integrating what they wanted again from negative 2 to 0 up. This was x squared plus 3x. Just to double check your answer. Guys, double check your answers. Come on. Double check your answer. So, negative 10 over 3. So we know we're correct. Now that we know we're correct, we don't have to check over anything. Guys, buy that calculator so you can check over your questions. You don't need to work it over and see if you're correct. You know you're correct. Now this part says a graph of f of x shown on Cartesian plane. The shaded region corresponds to the definite integral. Now, this they said this is the graph of x squared plus 3x. So notice the roots were minus 3 and 0. But where did they ask us to integrate from? From minus 2 to 0. So they ask us to integrate from x equal minus 2. This is minus 2, x equal minus 2 to 0. This was the region. So notice if I shade it, that's 1. This is 2. Then we have this piece and this piece. They're saying that this area would just work out is minus 10 over 3. So I love that question. So shade it, that's the region from minus 2 to 0. No problem. Now this says a function y of a single variable x, this satisfies the differential equation dy dx equal xy. It says briefly explain the relationship between differentiation and integration. So we can say differentiation and integration are inverse processes of each other. So we can say that is integration is an antiderivative. Right? Integration is the reverse process of differentiation. If you don't want to use inverse process, use the term reverse process there. Use the term reverse process. Cool. Now it says solve for the differential equation this here. So now we have dy by dx is equal to xy, and it says to obtain a general explicit expression for y in terms of the variable x and the constant of integration. Now to do differential equation by separation of the variable, you need to group the x and group the y. So we can notice we can divide both sides by y. So divide this side by y, or look at it as multiplied by 1 over y then. So this become 1 over y dy over dx equal x, because the y's would cancel. Then now we'll multiply both sides now by dx. We'll multiply both sides by dx. This becomes 1 over y dy equal x dx. Now we can integrate both sides. Let's finish it over here. We'll integrate 1 over y. We'll get ln y equal to, we'll integrate x. We get x squared plus our constant of integration c. But now we need to get it out of log form, so we just e to both sides. Now e to ln cancel each other, so we get y equal e to the x squared plus our constant c. That's it. Easy. Lovely. Now it says obtain the solution for the function that passes through 0, 10. So now if it passes through 0, 10, remember y is equal to e to the x squared plus c. So when y is 10, the x value is 0, so e to the 0 plus c. And so that means e to the c is equal to 10. Since e to the c is equal to 10, and y is equal to e to the x squared plus c, and we know we can rewrite that as y equal e to the x squared times e to the c by laws of indices. E to the c is 10. So y is equal to 10 e to the x squared. That's our answer. Y equal 10 e to the x. I'll finish. Now that we did that and we get it out of the way, the paper is finished. Intermath 2018 was so easy. We finished the entire paper. Alright, so I really hope that this was beneficial. Alright, if you enjoyed the video and you know that you learned something or the video was beneficial, go ahead, hit the like button, hit the subscribe button. It really helps the channel to grow. Guys, look at that. It's the next day now, it's 12 o'clock, right? Putting in the work for you guys so you will benefit. All right, and all I'm asking for, hit that like, hit that subscribe. I wish you all the best prepping for Intima, and the other papers will be coming soon. I can't upload all of them in one day. I'm trying to go one video per day. Trying. All right. So until next time, stay tuned. All the best practices.